Right, simultaneous equations are used to find the value of the numerical value of a variable, of a pair of variables or something like that. And in simultaneous equations you are given two sets of equations, of which you've got two pairs of variables, and you've got to calculate the numerical value of those variables in that particular situation. Okay. So, for example, you've got I don't know, z plus 5x equals 50, and y plus, sorry, no, that doesn't make sense, does it? And z plus 2x equals, I don't know, 20. Okay. So what we're doing here is using two equations simultaneously, hence the name simultaneous equations. So we're using two equations simultaneously to get a value of our variables, and our variables are expressed by the letters here and here. So first step is to number equations. Okay, so that's our first step. So I'm going to number this equation 1 and number this equation 2. Step 2 is to check same type of variable are equal. So just to make sure that either 5x, these x variables are equal, so 5x and 5x, which in this case they're not, or these z variables are equal, which they are because they're both z. Okay. 3, and then if not, multiply whole equation to make so. So if it's not, say you wanted the x values to be the same, you times this whole equation by 5 to make 10, times this one by 2 to make 10, and that would work, but there's no point because the x and z value is already the same. 4, apply signs same subtract, and signs same subtract is just a little memory thing to help you remember that if these signs are the same, then you subtract them, and if they're not the same, then you add them. That's all it is. 5, get value of one variable and substitute into original equation. Now then, I'm just going to demonstrate that using this. So we've got z plus 5, blah, 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 blah. Check number equations. We've already done that. 1, 2. 2. Check same type of variable are equal. We've got z, so equal. If not multiple, then make multiply equation to make so. We don't have to because that doesn't apply to us at the moment. 4. Apply signs same subtract. These signs are the same, so we subtract them. Biggest from smallest from biggest. Okay, so z take away z, that's 0z, so we've cancelled those variables out. That's the whole point of doing this. And 5x take away 2x, that gives you 3x, equals 50 take away 20, which is 30. So x equals 30 over 3, which is 10. Then get one value of variable and sub into another equation. We've got one variable and we sub this into here. So we've got z plus 2 times 10 equals 20. So z plus 20 equals 20. Therefore, z equals 0. So we've got z equals 0 and x equals 10. Now then, let's do some of these. So, number equations, 1 and 2. Right? Check values are the same. We've got the y's are the same, so that's okay. Apply signs, same, subtract. Or signs are different, so we add them together. 2x add 3x is 5x. Y plus minus y is 0, so they cancel out. 8 plus 7 is 15. So x would equal 15 over 5, which is 3. Then we sub into one of the original equations. So we've got 2 times 3 plus y equals 7. So 6 plus y equals 7. Therefore, y equals 1. So we've got x equals 3 and y equals 1. Again, I'm using Greek letters here instead of normal letters, just to make sure that you don't get confused. So you could have English letters or you could have Greek letters. This is the letter theta, and this is the letter lambda. You often see these symbols in physics and in maths. Sometimes you see theta for angles, you might see. But anyway, number equations, that's 1 and 2. And then you check whether the variables are the same, which they are not, so we're going to have to make them the same. Okay. I'm going to choose to make the lambdas the same. So, make a third equation. I've got to times the top equation, because the lowest common multiple of the lambda is 10. 5 and 2 is 10. I'm going to make lambda to make 5 lambda 10 lambda. I have to times by 2. So I've times this whole equation by 2. So I've got 4 theta minus 10 lambda equals 22. And then my fourth equation is I have to make this 10, so to make 2 lambda into 10 I have to times by 5, so 3 times 5 is 15 theta plus 10 lambda equals 5 times 7, which is 35. Then you just do it on here, so signs same, subtract, or signs different, so we add them together. So we have 19 theta equals these 10 lambdas cancel out. 19 theta equals 57. So theta will equal 3. Do 57 over 19 gives you 3. Then you sub into here again. So 2 times 3 minus 5 lambda equals 11. So 6 minus 5 lambda equals 11. So 11 minus 6, which is 5, so minus 5 lambda equals 5, so lambda equals minus 1. Okay, that's that. Now a different type of question is this wordy type of question. So we've got a man buys 3 coffees and 2 teas from a shop and they cost him £2.80. A woman at the same shop buys 1 coffee and 4 teas for £2.60. And what is the cost of 1 coffee and 1 tea? So we just have to express this in an ordinary simultaneous equation manner. So let's express the word coffee by C and the word tea by T, the letter T. So we've got 3C plus 2T equals 280. I'm just using the penny form instead of the pound form. 280. £2.80 is 280p. That's from the first line. The second line gives us c plus 40 equals 260. So we just apply this, then make the variables the same. I'm going to make the bottom the same as the top. So all I have to do is make one extra equation. So times the bottom equation by 3. So we get 3c plus 3 times 4, which is 12t, equals 260 times 3, which is 780. 780. And then, ignoring this one for a second, our signs are the same, so we subtract. Okay, so the c's cancel out. 12 take away 2 gives us 10t is equal to 780 take away 280, which is 500. So therefore t will equal 500 over 10, which is 50p. And if we sub 50p into here, so 3c plus 2 times 50p equals 280. So 3c plus 10p equals 100p equals 280. So 3c equals 180. Therefore, c equals 60p. So a cup of coffee equals 60p, and a cup of tea equals 50p.